In this video, I'm gonna be taking the Kohler 14 RCA head-to-head with the Predator 13,000 tri-fuel. And then I'm going to modify the Predator to add remote start so that I can fire it up from anywhere in the world. Based on price point alone, I am very skeptical of this Harbor Freight Predator, but at 1/6 the cost of the Kohler, I had to find out. Let's build a generator. Why didn't I go outside before doing this? Don't spill the oil, Riley. Let's put some gas in it. We know it has oil. I plugged in the battery. I think we go run and hit start. Oh, the fuel's off. On. And now it's time to test the generator and see if it makes electricity. We're gonna try charging the F-150 Lightning through the 240 volt plug. This is ridiculous that I'm charging my electric truck by burning gasoline in a generator, but at the same time, it's working. For those of you that are new to this channel, my wife Courtney and I live completely off grid on this property, meaning that we have to produce all of our own electricity. Most of that electricity is produced by that 10,000 watt solar array, and on sunny days like this, it has no problem keeping up. But in the wintertime, we have a lot of cloud coverage and minimal sunlight hours, which means that during the wintertime, we have to rely pretty heavily on that Kohler 14,000 watt standby generator. This is the Kohler 14 RCA, and to get us a little more room to work, I'm gonna tilt the solar panels. And I want to stop right here and say that I purchased both of these generators with my own money, and all of the opinions that I state in this video are my own. The first criteria is cost. This generator was on sale for $1,079.99. I also bought some zip ties. And while this Kohler generator retails for $4,300, by the time I had paid for the generator, the destination fee, a carburetor heater kit, I had to buy a battery for it, $5,887.59. There's still more costs associated with this, and all in, I think we're about $6,500 just into this generator. This generator costs exactly 6 times more than this one. I think right there, that's a pretty clear win to the Predator. Next up is portability. This generator weighs 240 pounds, this generator weighs 440 pounds, which means that this Kohler standby generator is dedicated to being here as a standby generator, as a backup to my off-grid system, where we really only use it for about 3 months of the year. You know, in the event of some kind of natural disaster, we could take this and go use it wherever it was needed most. Yet again, I think the Predator wins. Next up is fuel options. This Kohler comes all hooked up, ready to run on either propane or natural gas. The Predator is very similar in that it can also run on propane and natural gas, but it has another very cool feature, which is that it also runs on gasoline. I think that's an amazing feature because propane is extremely convenient. I can get a delivery truck up here to bring me large quantities of propane, fill our bulk container. I never have to pump it or transfer it or dump it, but I do have to rely on the delivery truck being able to get here. And this Predator generator has the best of both worlds. I can run it on propane or I can run it on gasoline, and I can always haul gasoline here in a pinch or like siphon it out of my neighbor's car if I need to, or my own car. I made up this list. I guess I'm sort of deciding who wins this test, but in my mind, there's another clear win to the Predator, which is that it has 3 fuel options, including the ultra convenience of being able to use gasoline in a pinch. Which brings us to our next one. How do you hook it up? This Predator generator comes set up with a 240 breaker. So right here we have 50 amp 240, but because it can only do 10,000 continuous watts, we only can use 42 of those 50 amps. We also have a 30 amp 240, the twist lock style that a lot of RVs use. And then also a whole bunch of 120 outlets right here, which means that right out the gate, as soon as you pull this thing out of the box, it's ready to start powering something. Kohler, on the other hand, here's how it hooks up. There's really no way to just quickly hook up a receptacle on this thing safely. You have to then run a sub panel with breakers and outlets and all the normal electrical stuff, which means that to use this generator, you really have to either have electrical knowledge or hire an electrician to get it all set up. Yet another win for the Predator. Next up is specs, output. This one says 14,000, this one says 13,000, which means that on paper they look pretty darn similar, but they're not. The Kohler generator is rated for 14,000 continuous running watts on propane or 13,000 continuous running watts on natural gas. Meanwhile, the Predator generator is actually only rated at 10,000 on gasoline, 9,000 on propane, 7,800 on natural gas, which right there gives a pretty clear win to the Kohler, but let's test those numbers.
I started by setting our off-grid inverters to be chargers only so that none of our household loads could affect these tests. These inverters are capable of charging our batteries at up to 20,000 watts, and they can easily handle the maximum output of either generator. Aside from monitoring the incoming electricity from our off-grid system's built-in monitoring software, I also set up a voltmeter, frequency meter, and an amp meter on the output of the generators. First up was the Kohler. I slowly turned up the charge current and monitored the results. At around 11,000 watts, everything looked perfect. It output 240 volts and 60 hertz frequency. As I stepped up the current, the voltage slowly started sagging. At 13,000 watts, the voltage was 117 volts per leg or 234 volts total, and the frequency was around 59 hertz. I could really hear the engine struggling to keep up. When I attempted to turn up the current beyond 13,000 watts, the frequency would drop below 57 hertz, and the generator would show a low frequency alarm and shut itself down. 13,000 was the maximum watts I was able to sustainably get out of the Kohler, which falls 1,000 watts short of its rated 14,000 watt output. Next up was the Predator. I set this test up the same way as I did the Kohler. On this one, it's running on gasoline, which should give the Predator its maximum power of 10,000 watts. At around 7,000 watts, everything looked good. I was seeing 240 volts and a frequency of 60 hertz. But as I turned up the current above 7,000 watts, the voltage started to sag and the frequency became too unstable for me to be able to measure. I could hear the engine RPM surging. At 8,000 watts, the voltage had dropped to around 110 volts per leg or 220 volts total. As I continued raising the current, the voltage continued to drop, and by 9,000 watts, the voltage was 103 volts per leg or 206 volts total. Beyond 9,000 watts, either the volts or the frequency fall below my inverter's acceptable threshold, and the inverters would automatically disconnect from the generator. So while technically the generator may be capable of generating more than 8,000 watts of electricity, the voltage falls outside of what I would consider to be an acceptable range. There could be a danger in running certain electronics with a voltage or frequency that are too high or too low. The Kohler generator stayed within what I would consider to be an acceptable voltage range, and the Predator did not. In my opinion, if a generator manufacturer gives a continuous output rating, the generator should be capable of generating that much electricity continuously. So I'm not awarding either generator a point for this test. "16-degree outside air, 80 degrees coming out of the vents means more than a 64-degree temperature differential that we're able to extract out of that 16-degree outside air." It's mind-blowing to me. I feel like I'm playing a video game because now the air coming out is 93 degrees. And in order to do that, we're only drawing roughly 2,200 watts.
Last summer, we installed this DIY all-electric central ducted system from Mr. Cool. It performed awesome the rest of the summer as an air conditioner, but I was a bit skeptical about using electricity to heat our home in the wintertime. With longer daylight hours and more sunshine to charge our off-grid power system, we've been using the Mr. Cool Hyperheat a lot lately, and I've actually been really impressed. The heat pump technology is able to use a compressor to transfer the heat energy from outside our home to inside our home, making it way more efficient than a resistance heater. And the inverter compressor can ramp up and down to match demand, further improving its efficiency. Together, those features make this unit ideal for anybody that's looking for an efficient, quiet, and DIY-friendly way to heat and cool their home, especially if you're looking to upgrade your existing HVAC system. Heavy. They specify 100-pound. Whoa! You have to hit the on button twice to turn it on, and I somehow just did that in my pocket. They specify a minimum of a 100-pound cylinder to run this generator on propane. So I stole it from the kitchen. It is completely full. I took it to town, filled it up. Okay. Propane goes here. Quick connect fitting, that's pretty nice. And hooks up here. Huh? What? it's not the right threads for the big bottles. It uses the big outside threads that the small bottles have, not the threads there. So how am I gonna do this? Next up, fuel consumption. And to be fair, both generators need to be running on the same fuel, so I'm gonna hook them both up to this 100-pound propane cylinder. They also need to be creating the same amount of electricity, so I'm gonna get them both set up to 5,000 watts of output. We're gonna run it for an hour, weigh the cylinder before and after, then we'll know how much fuel they use. First up, the Predator. And we need to get our before weight. 188.6 is the before on the Predator generator. I did have to get this adapter to be able to hook the regulator that came with the Predator generator up to this cylinder, but I was able to find it in town, so no big deal. All right, we're running the Predator now on propane. I've got a timer set for 1 hour, and we'll check our fuel consumption after that. Fast forward 1 hour, I've got the generator shut down. Let's see how much fuel it used. 180.4 afterwards, which is 8.2 pounds of propane. Next up, we're gonna hook this same propane cylinder up to the Kohler, set the Kohler to 5,000 watts, and see how much propane it uses. This is the line that feeds our Kohler generator. We normally run it off this 500-gallon tank, but for this test, we're running it off this 100-pound cylinder. Okay, got the Kohler running, timer set for 1 hour. We'll see you then. 173.4. Okay, the totals are in. We ran both generators for 1 hour at 5,000 watts. The Predator used 8.2 pounds, which is the same as 1.95 gallons, so it cost $5 to run it for an hour. The Kohler used 7 pounds of propane, which is the same as 1.67 gallons, and it cost $4.34 to run it for an hour. So the win goes to the Kohler. It's a more efficient generator. However, I was curious, and it would take more than 6,000 hours of runtime to make up the cost difference between these two in fuel savings. The snow today has me thinking about another comparison point between these two generators. While I have mine sitting under these solar panels, the Kohler is rated to just sit outside next to your house in the weather. Meanwhile, the Predator doesn't have an enclosure on it. Everything looks fairly waterproof, but I don't think that in the long run you'd want this thing just sitting out without a cover. It would need some kind of enclosure with ventilation. So I'm gonna go ahead and give the win to the Kohler in the weatherproof category, which brings us to the next test. We're gonna be testing noise. The Predator is rated at 78 decibels, while the Kohler is rated at 63 decibels. There's not a whole lot of information about where those tests are taken from or how far away or under what load. So we're gonna go to 5,000 watts and measure the sound. I've got a decibel sound meter here and let's find out. First up is the Kohler. Run. It's like 68 to 70 decibels right here. And if we go up right next to it, here we get 95 decibels. I got the Predator running. I had to mess with the choke a little bit, make sure it's charging. 101 decibels right here next to it. I will walk down the same distance down here next to the propane tank where we have 76 decibels. So the definite winner on the noise level is the Kohler, but it also has a sound damping enclosure around it. All right, we'll let the Predator run for a while. Let's talk about maintenance. Maintenance actually looks really similar for both of these. It's an oil change every 100 hours, checking the spark plugs every 100 hours, the air filter. However, there is one difference, which is that the Predator calls for the valves to be adjusted every 300 hours, while the Kohler does not require valve adjustments for the life of the generator, which means that from a maintenance standpoint, I'm gonna give the win to the Kohler. Next up on the list is warranty. Both of these generators have a warranty. The Kohler's warranty is a little bit strange. If it's installed in a backup standby situation in a grid-tied place like a home, 5-year, 2,000-hour warranty. However, if it's in an off-grid application like we are here, they reduce the warranty to only 18-month, 1,000-hour. However, that is way longer than the 90-day warranty that the Predator comes with. The 90-day warranty of the Predator is no questions asked, return it in store for whatever reason and they'll refund you. Beyond the 90 days, you have the option to pay $399 to add an extended service plan to this generator. I called Harbor Freight to ask what exactly was included in that extended service plan, and the way that they described it to me is basically that if there's obvious damage, like the generator fell out of the back of the truck and it broke in half, that's not going to be covered. But if there's any kind of mechanical or electrical failure, that's gonna be covered and they'll swap it out for free. If they can't replace it within 15 days, they'll give you a gift card for the value of the unit and you can buy whatever you want with that. At the end of the 2 years, you have the option that you can then renew the extended service plan for another 2 years for an additional $400. $400 seems like a pretty steep price to pay for a 2-year extended warranty on an item that only cost me $1,100, but at the same time, it means that I could run this unit for 3,000 hours a year, and when it eventually fails, because it'll probably eventually fail, I can walk in, get a new one, and walk back out again. So depending on the use, the extended service plan could be pretty valuable. I opted not to buy it. If you've been around the channel for a while, you probably saw that this actually is not the original generator that we had. The original one that we had some kind of manufacturing defect in the engine, and we had an engine failure after an hour and a half. I brought my concerns to my local dealer. They got right on trying to source me the replacement parts or whatever needed to happen to get my generator up and running again, but due to a national back order on these units, it took 6 weeks to get my warranty replacement in, which brings me to the next topic, which is service. All Kohlers are sold through dealers, which means that when I bought this generator, I bought it through my local dealer and was therefore assigned a dealer and a service center where there is a parts distribution network, qualified technicians. There are people that know how to work on, service, and fix this generator that are local to me. Meanwhile, the Predator basically has no service network. You're kind of on your own. The manual does have an exploded parts list, and there is a phone number that it says that you can call to get replacement parts, and that's about all I know about service and parts for these guys. Courtney and I are headed out of town to film a video that I'm very excited about. But before we can leave our home in the wintertime, there's a project that I need to get done. The project I'm working on today is removing the standard thermostat that we originally installed and replacing it with a smart thermostat. My headlamp just died. Courtney! One of the things that I think is really neat about this system is how easily configurable it is, which means that if you're thinking about upgrading your existing HVAC system, there's a good chance that this system will work with your existing thermostat. You don't need to pull new wires through the walls. The wiring configuration is done. My new wire is pulled, which means we are done in the attic. What do you call me?
Mr. Cool?
Oh no, I made a mess.
Ladder on top of the dog washing water trough.
Sorry, Mom. As long as I don't look down, it feels great. What's the good news?
Can you take your old messed up wall and we can cover it with a trim kit?
Okay, did you hear the outside unit turn on?
Oh, it's getting warm. All right.
Nice job.
Yes.
Between our auto start propane generator and our high efficiency electric heat pump system, we can now leave in the wintertime without worrying about our pipes freezing. If you'd like to learn more about Mr. Cool's complete line of DIY friendly high efficiency heating and air conditioning systems, click on the link in the description below. And now let's get back to testing those generators. Which brings me to the final comparison, which is actually the one that I am most excited about. It's the biggest difference in my mind between these two generators, and it's that my off-grid system can automatically start and stop this generator when it needs to recharge, where on this generator, I have to start and stop it when I need to recharge. But I have an idea, and I'm gonna see if I can figure out how to turn this automatic generator into an automatic standby generator that I can automatically start and stop with my off-grid system. So with that, let's head to the shop. Switches, not circuit boards. I was scared there was going to be circuit boards in here. Then I was going to have to try to decipher a PCB board. But these are switches with wires. Fairly sure I've got the first switch figured out. In stop position, the green and black wires are connected on this side, and I'm fairly sure they ground the magneto to stop the spark to the engine and stop the engine. And on this side, in the run position, these two white wires are connected, and I think that that powers the automatic choke. So we're gonna want our white wires connected to the normally open side of the relay and the green and black wires on the normally closed side of the relay. That way when the relay is energized, it disconnects these and connects these. I think I've come to the conclusion on the push button here that has 5 wires is that there's a lot more going on than it just being the push button that I was hoping for. It's got, I think, a timer in it. I'm not really sure. Looking at the remote, I'm pretty sure that this is just a switch. And when you press it, it sends the signal. Whoa! I didn't realize. I think that I'm going to cannibalize the remote to control the generator. There are 8 different styles of timer on this, and if you're interested in this, I'm gonna put a link to these down below so you can learn more about how they work. But I think that for our function, we're gonna wanna use function J. Function J basically says that when there's an input signal, wait a specified amount of time that I can program on this, and then turn on for a half a second. So I'm gonna use 2 relays, and basically I'm gonna make one wait, a half a second, turn on for half a second. The other one's gonna wait like 2 seconds and then turn off a half a second. So one of these relays is gonna control the switch down there. The other 2 relays are the timers that we need to simulate pushing the button twice. The first one's gonna control the run and stop switch. And then this is gonna be pushing the button in the remote once and pushing the button in the remote twice. I'm going to connect it, on, push once, push twice. I think it's gonna work. Printed bracket to hold all the timer relays together. I'm going to test my button push logic now. So I've got a continuity tester here that beeps whenever there's continuity, which is the same as pushing the button. So I've got it hooked up to these 2 leads. These are gonna get soldered to each side of the button. And now when I hook up power, yes! All right, now all I have to do is solder these into the button on this, and we'll have the push button start signal happen whenever power is connected. Now for the part I'm most nervous about, which is using this soldering iron that is way too big on these itty bitty connections. I think I need to just add a little more solder to that. Stop. Oh, I got it! 1 wire down. So on this side, I'm just gonna add a little more solder. I'm going to hook up power to the battery, and we should see the little LED light turn on this twice. I couldn't see it because I wasn't looking at the camera. Did it work? Woo! It worked! It worked! That's gonna send the signal to crank it. Now all I have to do is the last switch. I think if this works and this is a permanent solution, obviously we need a weatherproof enclosure for all of this. But right now, I just wanna know if it works. We're gonna unplug all of the wires from this switch. If I'm right, and I hooked all this up right, when I hit this, this generator's gonna start. Woo! Woo! And now, when the mid-drive system disconnects power, it turns off. Grenade! It works!
Works?
It works!
On its own.
On its own.
It has a mind of its own.
I can make the generator turn off and on now by just flipping a different switch. Okay, this little lever here is the choke, and I'm gonna go attempt to start it right now. And you'll see that it's gonna go to full choke, it's not gonna start, then it's gonna go to half choke and start. Half choke. By hooking it up this way, all of its original computer features, safety features, all of that stuff still works. We're just basically pushing this button and pushing the buttons on the remote just like I would. And I think that's what I really like about this way of doing it. I literally couldn't sleep last night because I was thinking about this generator and this experiment. So let's go test the generator. To recap, before we get this wired into our off-grid system, these 2 wires are the trigger wires for these timer relays. When I connect these wires, the generator will start and it will continue to run until I disconnect these wires. Let's test it. Full choke, now it goes to half choke. And we're running, and it will continue to run until these wires get disconnected. So this modification I'm making isn't just specific to my off-grid system, it would also work in automatic home transfer switches for a generator backup in a home. It's the same signal type that our Kohler generator takes. This is the wire that currently controls the Kohler generator. It goes right here into relay number 1 on our servo. We're gonna swap that out for a new piece of wire and run it over to the Predator. When I hit this button, this generator should start. Oh, that's awesome, it started. But now the question is it charging? Yes, it is. There it goes. It's starting to charge. Stopping in 5, 4, 3, 2, 1. Oh, it's so cool. And so now our Victron system can automatically, autonomously turn this generator off and on whenever it's needed. So which generator wins? That really depends on your specific needs. For me, I really like that the Predator can run on propane or gasoline. Since it's portable, I can use it for more than just charging my batteries 3 months out of the year. Since I'm charging batteries, I don't need it to be able to run at its maximum capacity, and I really don't care about the noise level. Which one is gonna last longer? I don't know, but at 1/6 the cost, I'm willing to gamble on the Predator. But I'd really like to hear your opinion, so drop it in the comments below. Which generator would you buy?